Okay, we're going to do a quick review of the unit circle. I haven't planned too much about what I want to say in this video, but I'll try to describe maybe some ways to help you remember parts of the unit circle. So first things first, it's called the unit circle because it has a radius of 1 unit. So all the points that you see that intersect the axes here, so this is the point 1, 0 in the xy plane. This is 0, 1, -1, 0, and 0, -1. Okay, so we've got our first 4 points on the unit circle. Now, what the unit circle allows us to do is evaluate sine and cosine of various angles and other trig identities as well, or other trig functions as well, once you know the identities. And there's some typical angles that get memorized on the unit circle. So I'll sort of write down a few of them, and then we'll talk about how to evaluate. The first ones I like to draw are the pi/4 angle. So if I do this, this is the angle pi/4, also known as a 45-degree angle. Okay, and then if you'll note with this positive x-axis, and you'll notice that from here to here, this is a 90-degree angle. This angle is also in radians pi/2. And then we've got 3 pi/4 over here. Oops. One sec. 3 pi/4 is this angle. And then all the way over here is the angle pi. The angle that we started with along the positive x-axis is just, you can think of it as 0. Oh, I didn't even write. I'm going to put this up here. Okay. The 0 angle, but you could go around the circle multiple times, and maybe that would be, we might have different values here. Okay, I'll get to that later. I like to draw these first because they just section off this upper half of the circle into fourths. So you split it in half, and then you split each half in half, right? So I've got pi/4, pi/2, 3 pi/4, and pi. The way I like to remember this is that I have one copy of 1/4. Like I have 1/4 of this piece of the circle. Then I have 2/4. 2/4. That's the same as 1/2. So I know that this was pi/2, 1/2. Then I have 3/4, right? 1, 2, 3. And then I have 1, 2, 3, 4/4, which is of the pi. Okay. So 1/4 of the pi/4, 2/4 of the pi/2, 3/4 of the pi, 3 pi/4, and the whole pi. One thing that might get a little confusing is that pi itself is just this half, the angle that's this half of the circle. It's 180 degrees. Okay, so don't think to yourself that it goes all the way around the circle. It just goes over the first half. Okay, and you could repeat this process in this bottom half of the circle. I'm gonna put the angles that sort of split this bottom half in half, and then those pieces. Let me make it look a little nicer. And then, whoops, splitting those pieces in half. Okay. And I just keep counting. When I draw the unit circle in my head, I keep counting the fourths at this point. So I have 1/4, 2/4, 3/4, 4/4, 5/4. So this is 5/4 of the pi. This would be 6/4. 1, 2, 3, 4, 5, 6. But 6/4 is equal to 3/2. So 3 pi/2. This was 6/4, 7/4, and 8/4 is 2. So up here I'm at 2 pi. All right. That's part of the unit circle. That's how I think about the sum of the angles. Okay, there are other angles along the unit circle that we commonly reference, other than the ones that cut it into sort of fourths. We also sort of cut the unit circle into sixths. So I like to think of a sixth. I know that 1/6 is less than 1/4. So that angle, the 1/6 angle, is going to be somewhere lower than this 1/4 piece, this pi/4 piece. How do I know that 1/6? How do I remember this? If I have one brownie and I have to split it between 6 friends, I'll get less brownie if I have one brownie and split it with 4 friends. Okay, so less. Okay. All right, so let's write down those angles. So somewhere less than pi/4, it's probably like ish, here-ish. I'll get rid of that so you can see. And actually, maybe I'll do this in a different color so you can tell which ones are which. I'll do this in pink. So somewhere here-ish is going to be pi/6. And then I'm going to count the same way that I counted the fourths. So I have 1/6, and then if I had 2/6, that's the same as 1/3. That's going to put me somewhere up here, and this will be the angle pi/3 from the positive x-axis. And then if I had 3/6, I would be at 1/2, so I'm here. Then 4/6 would be somewhere here, 4/6 of the pi. That's the same as 2/3. So here I've got 2 pi/3. And then that was 4/6. Then I have 5/6. 5 pi/6. And then 6/6, that's hard to say, puts me at 1 times pi. Let me make this 5 a little nicer. And actually, I'll make all these points orange so that it kind of matches. I'll leave the big ones blue. No, it's happening. Sorry, I just realized I think I want to make it color-coded like this. Okay. Then we keep going. So we have 6/6. The next one would be 7/6. So 7/6. Oh, that's way too wide. There we go. 7/6 is going to be 7 pi/6 is like here. 8/6 is the same as, if I cancel a 2, I've got 4/3. So here I have 4 pi/3. And then that was 8/6. 9/6 is 3/2. I already have that here. 10/6 is 5/3. So that's going to be this angle. 5 pi/3. 11/6 puts me here. And 12/6 puts me at 2 pi. Okay, that's all the angles. That's how I remember them. I just remember there's a pi/4 and a pi/6, and then I just count around, remembering that pi is like a whole pi is here, and then, I should get 2 pi over here. So I don't know if that's helpful. That's just how my brain does it. So if it's helpful, yay. Okay, now that's the angles. Now we want to think about this idea of sine and cosine in this circle. So where do those come up? You might remember sine and cosine from trig, not trig, yeah, but like geometry. And we often had triangles where we would have some angle, and then we would say, like, if my sides were x, y, z, I would say cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. Hopefully that's kind of what you have in mind. That's exactly what the unit circle is doing. It's saying what's cosine of, where in this little example I have here, this is pi over 6. And this forms a right triangle. And pi over 6 is a special angle. It's one of these like special triangles. Okay, pi over 6 is equal to 30 degrees. So you may have heard of a 30, 60, 90 triangle. That's exactly what this is. So we have a special relationship. When we have a 30, 60, 90 triangle, there's a special relationship among the side, the hypotenuse, and the two sides. You don't have to memorize that exists, but I just want you to know that that's why we see these values of like square root 3 over 2 and 1/2 and root 2 over 2. It's because they're special triangles. There's 30, 60, 90 triangles and 45, 45, 90 triangles inside this unit circle. Okay, now where this comes from is that for a 30, 60, 90 triangle, maybe I'm going to erase this eventually, but I want you to be able to see sort of what's happening. Here's an example. And there's my 30, 60, 90 triangle. Pretend that it's actually a right triangle because I drew that really terribly. But we know that if my, how do I want to say this? We have this relationship amongst the sides of a 30, 60, 90 triangle. I'll draw it off over here. That if I've got I drew this kind of badly. I'll draw it like this. Okay. In a 30, 60, 90 triangle, there's a shorter side and a longer side as far as the legs are concerned of the triangle. This will be the 30, this will be the 60. So the shorter side is always opposite the shorter angle. The longer side is opposite the bigger angle. And this is opposite the 90-degree angle. That's the longest side. That's the hypotenuse. There's this relationship that if the short side has value x, then the longer side has a value of x times square root of 3, and the hypotenuse has the side length 2x. Okay. For like, if I told you like, oh, I have a 30, 60, 90, and the short side has length 3, then you'd be like, oh, I know the other side is 3 root 3, and this is 2 times 3 is 6. Okay. Now, what do we know that's special about the unit circle? We know that the hypotenuse is the radius of this circle. Okay, so sort of connecting a lot of ideas here. The hypotenuse of this triangle is the radius of this circle, which is equal to 1. So in our circle here, I know that this side length, this hypotenuse side length is 1. So I would say x is 1/2. That tells me that the distance of this little short side is 1/2. And this longer side has a length of 1/2 times square root of 3. That's root 3 over 2. Okay, now you might recognize these numbers. These are exactly going to be the values that you sort of memorize in the unit circle. Now, if I wanted, this is theta, and I wanted cosine of theta, I would look at adjacent over hypotenuse. The hypotenuse, again, is the radius of this circle, which very conveniently is 1 because this is the unit circle. So root 3 over 2 over 1 is just root 3 over 2. And that happens to be exactly the same length of this side here, just because we have a unit radius. So cosine is the same, cosine of this angle is going to be the same as the x value of this point here. And if you did the same idea with sine of theta, you would do opposite over hypotenuse, 1/2 over 1, remember, length 1 here. Then I would get 1/2, and that's exactly the y value of this point. Cool. This argument works the same all around the unit circle. So let me get rid of some of these things so it's a little less messy. Okay. I don't know, I'll keep this off to the side, kind of cool. Now, that's for the 30, 60, 90 triangles. That's all of these triangles. So this one, the ones that had like the 1/6 sort of. So these sort of pink, I drew that really badly, but these pink triangles. This is kind of a cool picture. So all the triangles that are formed with this like pink color that I used, they're all 30, 60, 90. So they're going to have a value of like a √3/2 and a 1/2 somewhere in their like in their coordinates. Okay. The other triangles we've got here are 45, 45, 90. So let me, I wonder if it's easier. No, it's all right. Okay. So at these like pi/4 type points, this is a 45, 45, 90 triangle. So this is 45 degrees or pi/4. We'll call that theta for now. Now, for a 45, 45, 90 triangle, remember I said with this triangle that the shorter side is, or the shorter side is always opposite the shorter angle? Well, these two angles are the same. They're both 45 degrees. So their sides that are opposite them are also equal to each other. With a 45, 45, 90 triangle, let's see if I can, yeah, that's good enough. I'll make it a bit larger. Okay, I know that this, if this is theta, the two legs have equal length because the two angles opposite them are equal length. And if you used Pythagorean theorem, like a squared plus b squared equals c squared, you could find that the length of the hypotenuse is equal to whatever the length of the legs is times square root of 2. Okay. Now, again, we know that for a unit circle, this is the radius of the circle. It's also the hypotenuse of these triangles that we're looking at. And because it's a unit circle, that radius is 1. So the length of this side here, this hypotenuse is 1. That tells me that for this triangle I've drawn here, the side length x, the length of the legs, should be divide by square root of 2 on both sides, 1 over square root of 2. Now, you were probably taught to rationalize something like this so that you don't have a square root in the denominator. So let's just do that really quick. Multiply by √2 over √2, and I'll have square root of 2 over square root of 2 times square root of 2. That's the square root of 2 squared. So it just gets rid of the square root side. So the length here of this side is square root of 2 over 2, and of this side is square root of 2 over 2. And again, if we wanted to find like the cosine of this angle, pi/4, I could even let me write it like that. Cosine of pi/4. Pi/4 is this angle. So I would do adjacent over hypotenuse, and I'd get √2 over 2. I'd get the same thing for sine as well. That's where all of these numbers are coming from that you sort of memorized maybe at one point in your life and then forgot. But that's where they all come from. Now, I don't draw these triangles, these like little triangles, and remember these rules every time I draw the unit circle. That would drive me nuts. So what do I actually do when I think about the unit circle? I'll leave this up here in case people think it's interesting. What do I actually do? I remember this. I remember the pi/6 and the pi/4, and I sort of count around the circle. So that part I remember. Get rid of this little thing. Oh no. One sec. Okay. What I actually do is I think about so I guess what I also need to say here is that these coordinates, like I mentioned, where we had when I drew these triangles, the coordinates in this xy plane are going to be, this part gives us the cosine of the angle, and this part gives us the sine of the angle. So we saw that over here. So when I write down the x, y points, those are going to be cosine of theta. That was a terrible theta. There we go. And sine theta. Okay, we already sort of saw that for this point, cosine of theta is square root 3 over 2. So I'll write that here. And the sine was 1/2. How do I remember this? Well, I remember those three numbers, square root 3 over 2, 1/2, and root 2 over 2. Those are the three numbers that show up on unit circle. Then when I think about this angle, I think about which of these two lengths, which one's the longer one of the two? The longer one is going to be the root 3 over 2, because that's the bigger number. The shorter one will be the 1/2. So if I need to go farther along the x-axis than I do the y, the x is the root 3 over 2, and the y is the 1/2. That's what I do for all the pink sort of triangles that would be on this screen. Now the pi over 4, those are all the angles or the points are just going to be root 2 over 2 for all of them like that. Now look at this one. This is another 30, 60, 90 triangle, but notice the short side is this x part. The long side is the y part. So it's going to be like this point, but swapped the order. So this is 1/2 root 3 over 2. Once you have that, you can build the whole circle, because now all of these are going, like all the points are going to be very similar to these. It's just that you need to figure out whether you're going to the right and have positive x values, or your point is to the left of the y-axis and you'll have negative x values. Same thing here. If I'm going up, I'll have positive y values. If my point is down here, I'll have negative y values. So let's fill in the rest of this circle. Here I've got short side. So I've got a shorter side going in the x direction. That's a 1/2 type thing. And it's going left, so I need a negative 1/2. And the longer side is the one that was going up, so that's root 3 over 2. This is one of my pi over 4s, so I know that's got, it has to have root 2 over 2, root 2 over 2, but I had to go to a negative x value. 2 over 2. And then this point, the point over here is the same height and distance from the origin as this one over here. It's just that I had to go left. So negative root 3 over 2, 1/2. And we could fill in the rest. So I'm going to go ahead and pause the video and fill in the rest on my own and then come back so that you're not just watching me write these down. And I encourage you to pause the video and try to fill these in on your own before you continue. Okay, ta-da, they're all filled in. Now, as you practice with this idea, let me make this a little bit smaller. You'll get better at sort of picturing this in your head or remembering sort of the patterns that are involved. And then when you need to evaluate sine and cosine of these different angles, you'll remember that cosine is the x value and sine is the y value. So for example, let's say someone asked me, what's, actually, I'll make all of this a little bit smaller so I can do a couple examples. Oh, I'm going to need this whole thing. Okay, hopefully that's still easy-ish to see. And let me get rid of my little triangles over here. Okay, so examples. Let's say someone asked me on the street, they were like, stop right there and tell me what cosine of 3 pi over 4 is. What is it? Well, I would think about the unit circle and I would count. Here's pi over 4, 2 pi over 4, 3 pi over 4. I'm over here, okay? And when I'm thinking in my head, I know that these like over 4 terms have root 2 over 2, root 2 over 2, but I would have to go left along the x component in the negative direction and then up. So my x component here is negative root 2 over 2, and the x component is cosine. So if they had asked me sine, I would have said, well, I got to go left, but then I got to go up. That's a positive root 2 over 2 for sine of 3 pi over 4. Okay. Another one, what if somebody said, tell me what sine of 11 pi over 6 is? Okay. 1 pi over 6, 2 pi over 6, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6. Another way to think about that is that 12 pi over 6 is the 2 pi. So if I just go one less, I'm right here. So this tells me I've got my little triangle here. Cosine, so this is a 30, 60, 90 triangle. And I know that this is like the little side here. The longer side will be like a root 3 over 2 type thing. And the shorter side will be like a 1/2. Sine is the y value. So I know that I want this part here and I have to go down. So that's going to be negative 1/2. Okay. I think that's how my brain does this. I've never sort of said any of these ideas out loud before. So if they were helpful, that's great. If they weren't, I hope that you do find sort of a way that works for you to remember how this unit circle works. I highly recommend making flashcards and just practicing and practicing, because that's the way that you're going to remember all of these little things. If you have any more questions about this, please reach out, let me know. Otherwise, that's it.